There is a conducting sphere of radius r. If its radius is r, how the potential, electric potential, vary from the center to infinity. This is a conducting sphere. When this is a conducting sphere, what happens? If it is a non-uniformly charged sphere, or we say that it's a non-conducting sphere, the charge will be spread across this uniformly. But because this is a conducting sphere, charges can move from each other. When you give a charge, they repel each other. They all try to be as far away from possible. So every charge will try to reside at the surface. Only when all the charges are at the surface, the repulsive force between them is minimum. So they will all be at the surface. Because it is a conducting sphere, all the charges are at the surface. Then there is no net charge inside. Hence, the electric field inside a conducting sphere is 0. Hence, how do we draw the graph between electric field versus electric field here? And this is the distance from the center. At the center, r is equal to 0. So here, r is equal to 0. Electric field is 0. Since there is no charge inside the whole sphere, from r is equal to 0 to r is equal to radius of the sphere. So r is equal to radius of the sphere. Electric field is 0. So it will be here 0. Then at the surface, electric field will be equal to q by 4 pi epsilon naught r square. So this value increase up to this point. Here this value of electric field at the surface from center to here, 0. At this point electric field is this much, q by 4 pi epsilon naught r square. Then when the distance is going, when r is increasing, the electric field is inversely proportional to the distance r square. Then it will fall down rapidly, but only when r is equal to infinity, the electric field becomes 0. Hence it will never touch the x-axis, the x being r axis. So we are supposed to write the electric potential versus distance graph. Electric potential versus distance. We know that electric field is minus dV by dr. From the center to the surface, electric field is 0. That means electric field is 0. Then dV by dr is 0. Only when V is a constant with respect to distance, the electric field will become 0. Hence V is constant until the surface V is constant. So it will be like this. Here it is V, the distance is r. At the surface, the value of the electric potential is equal to q by 4 pi epsilon naught r. So this value V equal to q by 4 pi epsilon naught r. After that, as you move away and away from the sphere, it is potentially inversely proportional to r. If this falls very rapidly, this falls very slowly. And finally it will reach the infinity. It will reach the x-axis only when r is equal to infinity, because V is inversely proportional to r. Only when the distance r is equal to infinity, V also becomes 0. Both electric field and potential are 0 only at infinity. So both the graphs will touch the x-axis at infinity, but the fall of this graph, electric field graph, is more because inversely proportional to r square, but the fall of potential graph will be less because it is inversely proportional to just r. So here the option happens to be B.